Good morning. Before we begin, I just want to remind you, if you're watching this video, please make sure it is after you have already watched the Ed Puzzle Area and Perimeter of Rectangles video. It's pretty self-explanatory as to what it's describing and explaining, but just watching that video and answering the questions have given you 10 points out of today's 20 points. The other 10 points come from working on IXL 7.AA.1, linked in Google Classroom here. Again, SMART score of 85. If you cannot accomplish a SMART score of 85, if you work for 30 minutes or more on that and still can't get it, you will get credit. But please, if you're working that long and still not getting it, you should be coming to my office hours and asking questions. Today we're talking about properties of quadrilaterals and how can perimeter and area be found. So before we begin, we're going to start by classifying these triangles by their sides. This triangle has one tick mark here and one tick mark here, indicating that those two sides are the same. And since this side has two tick marks, this side is different than those other two sides. Therefore, this is an isosceles triangle. This triangle, each side has its own unique number of tick marks, meaning all three sides are different length. Therefore, this triangle is scalene. And finally, this triangle, all three sides have one single tick mark, meaning all three sides are the same length, making this an equilateral triangle. We don't know any of the angles on the other three triangles, or the other two triangles, except for the fact that we know that they all add up to 180 degrees. But the third triangle being equilateral, we know that each angle is 60 degrees. All right. So today, first we're going to talk about types of quadrilaterals, okay? So this is a little bit of a flow chart, if you will, or a family tree of quadrilaterals. Quadrilateral is the name for any four-sided polygon. It could look like this. It could look like that, okay? That's a quadrilateral. If it has four sides, it's a quadrilateral. If it's four sides in a polygon. Another name for a quadrilateral is quadrangle. And that means the exact same thing as quadrilateral, because if something has four sides, it has four angles. Quad means four, lateral means side, quad means four, angle means angle. Quadrilateral, four sides, quadrangle, four angles, the same thing. Okay? I'm going to start off by going off to the right. We're not going to talk much about these, so that's why I want to kind of talk about them right now, and then we'll just toss them to the side for a little while. We're not going to do area of kites in this class, but please know that a kite is defined by having two adjacent congruent sides and no parallel sides. So these two sides are the same, and these two sides are the same, but none of them are parallel. Okay? We're going to go over here first to a trapezoid. A trapezoid has two parallel lines, or what we say one pair of parallel lines. So it has exactly one pair of parallel lines, and these parallel lines are indicated by these arrows, okay? So it means that this line is parallel to this line. That means that if we extended them forever and ever and ever, they would never touch. And then these two sides can be whatever the heck they want, okay? But these two sides, top and bottom on this, are parallel. Now, of course, if I turn this on its side, it's still a trapezoid, okay? It's just that now this side is parallel to this side. Doesn't matter, it still makes it a trapezoid. It doesn't have to have the bottom and the top be parallel, but the parallel sides are what we call bases on a trapezoid. We'll talk about that more tomorrow. We also have an isosceles trapezoid, and an isosceles triangle, if you remember, two sides are the same. In an isosceles trapezoid, two sides are the same. So here we have our base, which is our parallel sides, okay? So these are actually our bases. And then here, these two sides, as shown by this tick mark, are the same length. That makes that an isosceles trapezoid. And then on to the middle here, we start with a parallelogram. A parallelogram is a quadrilateral where opposite sides are parallel. So this side is opposite this side, and they are parallel. And this side is opposite this side, and they are parallel. It doesn't matter which way the arrows are going, it's about the number of arrows. Just like if we have an equilateral triangle and we have one single tick mark in each side, okay? If we have a parallelogram, the fact that this has one arrow going up and this has one arrow going up means that these are parallel. The fact that these have two arrows means that the sides with two arrows are parallel to each other. Okay? Now, all of these shapes that are below the parallelogram are also parallelograms. They are just more specific parallelograms. Okay? So we're going to go first to the rhombus. The rhombus is a parallelogram. So I could do, if I wanted to show that, I would put an arrow here and an arrow here, and then I could put two arrows here, and I would put two arrows here. So a rhombus is a parallelogram where all four sides are the same length. All right? So this is in itself a parallelogram, but it's a special parallelogram because in this parallelogram right here, it doesn't matter. These two sides are going to be the same length, and these two sides are going to be the same length, but doesn't matter. Doesn't mean that all four sides are the same length. Okay? And now coming down to here, we have a rectangle, and a rectangle is a parallelogram. So we can show that here. Okay? But a rectangle is a parallelogram with four 90-degree angles. All right, so we know that rectangles are nice. They've got these 90-degree angles that makes them special shapes. And if you combine the qualities of a rhombus with the qualities of a rectangle, we get a square. A square is a parallelogram where all four sides are the same and all four sides have 90-degree angles. So that combines what makes rhombuses special with what makes rectangle special to give you what makes a square special. It's a special parallelogram. So, is a square a parallelogram? Yes, it is. Is a square a rectangle? Yep, a square is a rectangle. By definition, a rectangle is a parallelogram with four 90-degree angles. A square is a parallelogram and it has four 90-degree angles. It's just a special parallelogram and a special rectangle. Okay, so this is what I like to tell students who get confused with this. Are you a student at Sparta SMS, Sparta Middle School? Yes, you are. Are you a 7th grader? Yes, you are. Are all 7th graders students at Sparta Middle School? Or are all Sparta 7th graders at the middle school? Yes. But does that mean that all middle school students are 7th graders? No. Are all squares rectangles? Yes. Does that mean that all rectangles are squares? No. The square is a special rectangle. A Sparta 7th grader is a special middle schooler. Okay? We can go over that more if you need any help with that. All right, so on to the area of a triangle. We did area of a rectangle in that video that you watched already. So on to area of a triangle. The area of a triangle is half the base times the height. Now, the base, a triangle actually has 3 bases. Any side of a triangle can be the base. It doesn't have to be the bottom of your triangle. But what is key is the height is the distance from the base perpendicular to the highest point on the triangle from the base. So if I'm going to make this my base, then my height has to go at a 90-degree angle from the base to the tallest point or furthest point away from the base. Okay? Now, what I've done here is I've taken 3 triangles, but all 3 of these triangles are the same triangle. All I did is, if you look at the letters, Okay, I just rotated these triangles. So if I wanted to look at this as being the base of my triangle, which is EF, the height would be 90 degrees from this point up to the tallest point. So a lot of times it isn't done that way. A lot of times what we do is, in order to measure straight up from the base to the tallest point, which this would be the tallest point, what we do is we extend with a dashed line our base, and then we draw, and this is our measured of our height. Okay, at a 90-degree angle, we measure from here up to here. This is our height, and this is our base. Here, oh, Jesus. Jeez Louise. Oh, then there we go. Too far that way. All right, come on. If we look at our triangle here, if this is our base, then our height would be straight from there to there. You notice that your height is not one of your sides. It can be in a right triangle, but it's not if it's not a right triangle. So in this case, this would be the base and this would be the height. And then finally, if I rotate a little bit more, I can make this my base, but then my height would be, if I measured, see that 90-degree angle I make? This would be my height and this would be my base, okay? If it's a right triangle, then yes, your sides are going to be your base and your height. But if it's not a right triangle, then you have to figure out what your height is, and it's measured. It's not one of, we call these slant heights. They're not heights, okay? Now, if we look at this triangle, remember, area of a triangle, every shape has its own area formula. Area of a triangle is half times base times height. We notice that this is all multiplication. Does it matter what order we do multiplication in? Nope. So you can do the base times the height and then do half of that. You can do half of the base and then multiply that by the height, or you can do half of the height and multiply that by the base. The order you do the multiplication doesn't matter. And don't forget, half of anything is the same as dividing by 2. So in this, we have a 90-degree triangle here, or right triangle rather. Okay, so this could be considered the height, and this could be considered the base. If I did half of 5, I'd get 2.5, and then I'd have to do 2.5 times 6. Instead, what I can do is 6 times 5 is 30. Half of 30 is 15. Therefore, the area of this is 15, and area is always units squared. Okay. So in this case, our triangle here, we have the base. This right here represents the height. So this base must be 10, because from here to here is 3, from here to here is 7. The whole base is 10. So we do half of 10 times 6. We can do that in any order we want. I'll do half of 10 is 5. 5 times 6 is 30. So it's 30 millimeters squared. This triangle, this right here means nothing unless I had something like this. I don't have that length, but I do assume on this one that this is 90-degree angle. This is a right triangle. It is, but you'll learn that again later on. So I'm going to do half times 8 times 6. In any order you want, you get 24. Here we have a base of 14, so it's half of 14, a height of 5. I'm going to do half of 14, which is 7. 7 times 5 is 35. All right, are we getting this? Are we understanding? Here's where they'll see how they showed you the height here. So here we have half of 9 times 10. I'm not going to do half of 9. I don't want to do half of 9 and get 4.5. 4.5 times 10 is 45. That seems silly. I'll do half of 10, which is 5. 5 times 9 is 45. I get the same answer, except I didn't have to deal with decimals. And then finally, of these three, here's my 90-degree angle, which means that this can be my base. So half of 5. This would be my height times 12. I'll do half of 12 is 6. 6 times 5 is 30. 30 kilometers squared. Okay? Make sure you work on that IXL. Here's just a reminder, area of a rectangle is length times width, and area of a square, since the length and the width are the same, you can just take one side, multiply it by itself, which is squaring it. All right, have a good day. I'll see you tomorrow.